Welcome to Structural Analysis 2 video series. Unit 5th Approximate Analysis of Multi-Story Frame. Topic Numerical on Analysis of Frame by Cantilever Method. Part 1. Now this is a numerical based on Cantilever Method. This is the second part of unit number 5th Approximate Analysis of Multi-Story Frame. Before this we were discussed about the portal frame method. Now this numerical is based on cantilever method. So numerical statement as follows: determine the approximate value of a moment, shear and axial forces in the member of a frame loaded and supported as shown in figure using cantilever method of analysis. Area of each exterior column is one half of the area of the interior column. Now we have to find out the moment, shear force and the axial forces in the member by cantilever method. Now in the problem it is mentioned that exterior column is one half of area of interior column. So the if our exterior column is a by 2, that means the interior column is a. So that means exterior column, we can write down like this: exterior column is equal to 2a. A means interior column and this a means exterior column. So this is a relation that we have: exterior column is equal to 2a. Now first let divide the this midpoint of a beam or column, or let assume that midpoint is nothing but the point of a contraflexure. Mark these midpoint as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these all are the midpoint of a beam and column, and those we are assuming as a contraflexure of a respective element. Next step, let determine the CG of a frame. Now we know that the exterior column is if A, uh, interior column will be a 2a as per the relation given in the problem statement. Now to find the CG of a frame, taking a moment of area of a column at the leftmost column axis. So let's consider as that column. Let's say this one is a column, first column of A1, and taking a moment of area of a column about that about this column. So the if this column is a1, the the distance would be 0, plus second column is a2 column, and the distance between these two columns is 4.5. Next column is a3 column, and distance between the a3 column up to this first column is 10.5. So the this first column is a1, and distance about the column itself is 0, because the CG, we are calculating the CG of frame, and we are considering the locating, try to locating the CG with respect to this left column. So a1 into 0, next is a2 into 4.5, next is a3 into 10.5 is equal to a1 plus a2 plus a3 into x bar. So we will get the x bar by putting, now here let put a2 is equal to 2a, because a2 is interior column, and we know that interior column is nothing but 2a of exterior column. So here let put a1 as a and a3 as a, because these a1 and a3 are exterior column, so let call them as a, and interior column let put as a 2a. So by solving this, and we will get the x bar is equal to 4.875 meter. So this is a distance of a CG, central axis of a frame, with respect to this leftmost column, and the distance is 4.875 meter. We know the distance between each column, and also we know the now the central axis is 4.875 meter from the leftmost columns. Now find out the uh, distance of each column from the central axis, and that distance as shown here, it is for this integral column it is 0.375 meter, because we know the distance between these two column, and we know this x bar, so we can calculate this point this distance is 4.5 between these two columns, so this remaining distance will be 0.375. Similarly, we find out for the last A3 column. Now we know the total distance between these two first and last column is 8.5. So 8.5 minus this 4.875, we will get 5.625 meter. So likewise find out the distance of each column from the centroidal axis or CG of a frame, and that axis we are considering vertical axis. Now consider the upper story, cut this column from the center from the node 3 4 5. So this distance will be 1.5, half of this total column length. And let see the and show here at node 3 4 and 5 the forces, that means axial force and shear force and axial force, which are acting at this node. So here the H3, H4 and H5 are the shear forces which are acting opposite of a 25 kilonewton force which is acting at G. And also we are assuming the V3 V4 which is axial force of each column in a downward direction, and opposite to this centroidal axis, that means right side of a centroidal axis, we are consider V5 in the upward direction. So these are our assumption. Let's consider the horizontal forces acting on this FBD. So the all these shear forces, if we add together, they have to balance this 25 kilonewton force. That means we can write down like this: H3 plus H4 plus H5 is equal to 25. And now taking a moment about the point P. So by taking moment about point P, we have V3 into the distance or lever around 4.875 meter. It is rotate in anti-clockwise, so positive. Next is V4 into 0.375, positive, and this one V5 acting up, so if you rotate it will be anti-clockwise, so it will be a positive. V5 into the this distance is 5.6525 is equal to the horizontal forces. Take moment of horizontal forces, and that horizontal forces create the moment about the P. Let's take one by one. H3, if you rotate, it will rotate in a anti-clockwise clockwise sense. All these rotate in a clockwise sense, their sign will be minus, and this distance is 1.5. So H3 minus H3 minus H4 minus H5 into 1.5, keep in bracket. If you take toward the right hand side, they become positive. So H3 plus H5 plus H5 H4 plus H5 into 1.5. Now what about this 25 kilonewton force which is passing through point P? So it become 0. So total forces in the moment the moment calculation, uh, they are 1, 2, V3 and V4 will be there. This V4, V5 and V3 is there. V4 is passing, yes, V4 is also there. P point is here. So total forces are 3, V3, V4, V5. Yes, they are there. And this horizontal forces are also 3. So they are there. Only this 25 is passing through P. So that's why its moment will be a 0. Now, one more thing is here is that as per the assumption, axial force in the column is proportional to its distance from the centroid and the area of a column group at that level, or we may call it as like this: the ratio of each column, that means the stress to distance from the CG, that ratio is equal. So let's take each column's ratio. This ratio, first column is V3 divided by area of a column divided by its distance from the centroidal axis is 4.875. This one is our centroidal axis. Then next column is V4 divided by area is 2a, and the centroidal axis is 0.375. So this one is a ratio is equal to last column V5 divided by area a, and the centroidal axis is 5.625. So by simplifying this one, we have value of V4 and V5 in term of V3, and that value will be for V4 it is 0.154 V3, and for V5 it is 1.154 V3. Now consider the equation of a moment. This is equation of a moment. In this equation, put V4, V4 and V5. So we will get the left hand side in term of V3. So after putting, we having this equation. Now see the right hand side. There is S3 plus H4 plus H5. So put this is equal to 25 here. So it become 25 into 1.5. So by simplifying, we have V3, and that V3 is equal to 3.283. So once we know the V3, put this V3 here, we will get V4 and V5. So we have V4 and V5. V4 is 0.506 and V5 is 3.789. Now mention here the value of V3, V4 and V5 as calculated in previous slide. Now consider the G joint, and here let us assume V1 in upward direction and H1 toward the left hand side, and let apply the summation Fy, Fx and moment equation for that G joint. So summation Fy is equal to 0, upward is positive, downward is negative. So plus V1 minus this 3.283 is equal to 0. We have V1 is equal to 3.283 kilonewton. Take moment about G. So for taking moment about G, the axial forces will be passing through the G. So their moment will be 0. Only the perpendicular forces to the member that we have to consider. So V1 rotate in a anti-clockwise direction. So V1 uh, into 2.25, here the value of V1 we calculated. So put that value of V1 3.283 into 2.25, and H3 is unknown. H3 into 1.5, H3 will rotate in a clockwise sense, so minus sign is there, is equal to 0. So we have H3 is equal to 4.925 kilonewton. So let's do the summation Fx. So summation Fx, for that right side is positive, left side is negative. So right side is plus 25 minus H1 and minus H3. H3 we know 4.925, put there. We have H1 is equal to 20.076 kilonewton. So we have value of H1, and also we have value of V1. Now show the opposite arrow because this one is a common joint, and put the same value or magnitude. Now this h1, let we assume toward the uh, left hand side, keep as it is, and v4 we know as calculated earlier, downward direction 0.506. Now these two, let assume upward v2 and left side h2. These are our assumption for this h joint. Let apply summation fy for h joint. Upward positive, downward negative. So the upward is v2 plus v2 minus 3.283 minus 0.506 is equal to 0. So v2 is equal to 3.789 kilonewton. Take a moment about h. So our sign convention are clockwise minus and anti-clockwise positive. So the 3.283, it will rotate in a anti-clockwise sense, and lever arm is 2.25. The next is h4, it will rotate in a clockwise sense, so h4 into 1.5. Next is a v3 v2 into 3, but we know the v2 value 3.789 into 3 is equal to 0, so it become h4 is equal to 12.503 kilonewton. Now let do the summation fx is equal to 0. So by doing so, taking a right side positive and left side arrow negative sign, we will get the value of h2 by just adding h1 and h4. We will get the value of h2 is equal to 7.573 kilonewton. Now once we have these two value, take opposite arrow for the corresponding joint, and same magnitude you have to keep, because they are, we know from this h joint. And here h5 toward the left side and v5 in upward direction as from the previous slide. h5 is unknown here, so do the summation fx is equal to 0. These are the sign convention. So h5 minus h5, and this one is plus 7.573 is equal to 0. So we have h5 is equal to 7.573 kilonewton. So this is about the upper story and the forces in the upper story. The remaining part will be resumed in the next video. So let we stop here.